Hello guys, welcome back to Chemistry Digest. On today's topic, we'll be discussing how to calculate oxidation number. But first, let's define oxidation number. Oxidation number is simply defined as the charge an atom has in a compound. It is very important to know the oxidation state of atoms of elements in a compound because it enables us give the appropriate nomenclature of the said compound. Now, there are certain rules that must be adhered to while calculating the oxidation number or state of a given element. So, number one is that the oxidation state of any element in a free or uncombined state is 0. So, provided an element is not combining with another element other than itself, the oxidation state or number remains 0, as you can see in chlorine gas and oxygen gas. So going to the second rule, we have that the oxidation number of a single element ion is equivalent to the sign and charge of the ion. For example, in sodium ion, the oxidation state is +1. In potassium ion, the oxidation state is +1. It is important to note that anytime you see a charge, whether positive or negative, just know that the coefficient of the sign is 1. So altogether it can be +1 or -1 depending on the charge of the ion. For example, in the case of potassium ion and sodium ion, like we discussed earlier. So for magnesium ion, the oxidation state is +2. For aluminium ion, the oxidation state is +3. For chloride ion, it is -1. Take a look at chloride ion. There is no number there, so automatically it becomes 1. We still maintain the charge minus, so altogether -1. I hope it's making sense. Going to the third rule, which we'll be using most times in calculation questions, it states that the sum of the oxidation numbers of elements in a neutral compound is equal to 0. So all these compounds, as you can see, are neutral compounds in that they don't have any charge, as the positive and negative ions combine to neutralize each other, forming them. Alright, it is a good idea to learn the activity series of cations and anions. Why is it important? It is important because you will need it to memorize their charges. You will also need it in electrolysis questions. You will also need it to know metals that can react with acids to liberate hydrogen gas and a corresponding salt. Okay, that's by the way. Please, I'll suggest you come up with a mnemonic to help you remember both the activity series of electropositive ions and that of electronegative ions. I hope you all know what a mnemonic is. Okay, for those of you that don't know what a mnemonic is, it's just a memory aid that helps you remember information easily. It could be a rhyme or a song, alright? Alright, there are other situations we need to take into consideration, which is that the oxidation state of oxygen is always -2 when combined with other elements, except in peroxide, where it is -1. Also, in oxygen difluoride, where it is +2. As for hydrogen, it is always +1, except in metallic hydrides, where it is -1. Metallic hydrides are just compounds formed when hydrogen combines with metals. Alright, so let's find a solution to this problem. It says, find the oxidation state of manganese in KMnO4. I'm not going to give the IUPAC name. At the end, we're going to find out what it's called. Alright, so first of all, you want to say that the sum of all the oxidation numbers of KMnO4 as a compound is equal to 0. So just below that, you express that rule mathematically by summing up the oxidation states of individual elements to give you a total of 0. So here we have it that potassium, which is +1, will be added to manganese, which we are looking for, plus oxygen, which is -2, but there are 4 atoms of oxygen there. So altogether, we're going to have -2 multiplied by 4, which will give us -8. So at the end of the day, their sums should equal 0. So when we collect like terms and make manganese the subject of the formula, we have +7. Please make sure you include the sign for clarity purpose. So +7, as in this case. So manganese has an oxidation state or oxidation number of +7. Hence, why the compound is called potassium tetraoxomanganate 7 and not potassium tetraoxomanganate 4. Some people will be calling it 4. So, manganate, as in manganese, alright? So, it is manganese that we are looking for the oxidation state. Alright, so let's move on to the next calculation. We're asked to calculate the oxidation state of carbon in Na2CO3. Some people like calling it Natuco3. Alright, so let's use that to find out the IUPAC nomenclature. So we follow the same procedure to get the oxidation state of carbon as plus 4. Alright, so hence it is called sodium trioxocarbonate 4 and not carbonate 3. Fantastic. So the last question for today is to find the oxidation state of chromium in K2Cr2O7. So potassium's oxidation number is +1, but there are 2 atoms of potassium in K2Cr2O7, so we'll have +2 instead. Always look out for the number of atoms involved so you can multiply it with the normal charge of the said ion. Alright? So chromium, which is what we are looking for, has 2 atoms, but we don't know its oxidation state. So we just put down 2Cr, alright? That is how you express any element you're looking for its oxidation state, if it has a coefficient or a number multiplying it. So oxygen is -2, but it has 7 atoms. So altogether, we're going to have -14 oxygen atoms. Alright, so after we collect like terms and make Cr the subject of the formula, we're going to have +6 at the end of the day. Hence, the IUPAC nomenclature is potassium heptaoxodichromate 6 and not 7. Alright, hope you learned 1 or 2 things from this segment because we have some questions to try. I'll be looking forward to your answers in the comment section. See you in the next video. Bye.